All right, so in this section we're going to be working on section 1.5. So our learning targets for the day is I can rewrite literal equations, and we'll talk about what literal equations are. I can rewrite and use formulas for area, and then I can rewrite and use other common formulas. So let's go ahead and take a look at our lesson. So sometimes equations have more than one unknown variable. We've been looking at equations that have one unknown at this point, most of the time x, and solving for that x. Sometimes we'll have more than one variable, but we still need to be able to solve that equation for a variable. And now just remember, solving means getting that variable by itself. So here's our first equation. We're going to solve the literal equation. So a literal equation is an equation that has two or more variables. This would be a good vocab word if you haven't written this one down yet. So I have to solve the literal equation, 3y plus 4x equals 9 for y. So I can see that I have my two different variables here. I have x and y, and I'm solving for y. I'm told what I'm solving for. So the first thing I always want to do is write out my equation. Then I want to get this y by itself, so I want to undo what's being done to it. So I see that I'm adding this 4x. And I want to think of 4x, since I'm not solving for x, I want to think of this as one thing, not 4 and an x, it's a 4x. So to undo this 4x, I go ahead and subtract it because it's being added. So I subtract 4x from both sides, which gets rid of it. So I'm left with 3y equals 9 minus 4x. So we see that this 9 and 4x have to be written separately because they are very different terms. So now I see that I have 3 times y. So I need to undo that. So I go ahead and I divide everything, divide each side by 3 to get that y by itself. And then I can further simplify. So 3 divided by 3 here with the y was 1. I know that 9 divided by 3 is 3. And I know that 4 divided by 3 is not a pretty number, so I just leave it as 4/3. So here, this right here is my final answer. So then I can just go ahead and rewrite my final answer is y equals 3 minus 4/3 x. These two equations are the same thing. And in a few units, you'll understand why we need to be able to go back and forth between these two forms. Okay, so that was example number 1. So here is example number 2. So you'll see I have y equals 3x plus 5xz. And I'm being asked to solve for x, so I want to get x by itself. So I always write my equation first. Then the next thing I notice is that I have an x in both of these terms. So I want to use the distributive property, right? In distributive property, I generally go from parentheses to something without parentheses. However, it works backwards as well. Since there's an x in both terms, I can pull that x out front here. And if I was to do the distributive property, I would get back to my original equation, so I know I'm right. So I go ahead and use the distributive property. Then I see that I'm multiplying x times this other thing. So now I know I can go ahead and divide each side by my 3 plus 5z. And I do that, the whole thing. And then I can just simplify. This goes away on the right side. And I know that none of these terms can cancel out or simplify on the left side, so I just write it and leave it like that. So then I rewrite my final answer is just x equals y divided by 3 plus 5z. So here's example number 3. So the formula for the surface area of a rectangular prism is S equals 2LW plus 2LH plus 2WH. I'm asked to solve the formula for the length L. Now this will come in handy because oftentimes we'll be given the surface area or the volume of something and be asked to find one of the missing lengths, side lengths. So here's the easiest way we can do it. So I always start by writing my equation, and here I'm given the equation. So we're kind of combining what we did in example 1 and example 2. So I see that here I have two terms with L in it, so I want to keep them together on one side of the equal sign and get everything else to the other side. So I'm going to go ahead and I subtract this 2WH because there's no L in this term, so I want to get it to the other side. Okay, so then I simplify. So now I have S minus 2WH equals 2LW plus 2LH. Now, just like our last example, I have an L in both of my terms, so I can go ahead and use the distributive property to get that L separated a little bit. And again, I'm multiplying, so I went ahead and undo that. So I divide by 2w plus 2h, and then I can simplify again. And when I'm looking at this left side, I don't see any other simplification that can happen between all of my terms. So I know that that's going to be my final answer, is my L equals S minus 2WH divided by 2W plus 2H. So here's a word problem we can look at. So we own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet. To pay for a new water system, I'm assessed $5.50 per foot of lot frontage. So the first thing I have to do is find the frontage of my lot. So here's a little picture of what I'm looking at, right? I always draw a picture to start with. So I know that it's a rectangle, so that helps me. And I know that it's 500 feet deep. And I know my total area. So I start with my picture and my area of a rectangle. And I know that A, the area, equals length times width. So then I can plug in the things that I do know. So, and I know that I'm looking to find W, right? I've been asked to find W. So in order to get W by itself, I divide both sides by L. Now I put in what I know. I know that my area was 100,000. And I know that my length was 500, so I can go ahead and do this math and get my W equals 200. Now remember, the easiest way to do that is to start simplifying my zeros to be able to divide that. So that's what the width is. So then on my picture I could draw this back in, and I know that my width is going to be 200. So then the second part of the problem is, how much are you assessed for the new water system? Well, I know I'm assessed at $5.50 per foot, so then I can continue to go here. So each foot of frontage costs $5.50, so I can set this up as my simple equation, that it's $5.50 per foot, and I know that I have 200 feet, and then I see I have feet in the denominator and feet in the numerator, so those units cancel, and I can multiply straight across. So I end up that my total assessment is $1,100. All right, so here's one of our core concepts. These are some common formulas. So go through and make sure that you have these, because we're going to use them several times. I'm looking at the temperature formula between Fahrenheit and Celsius. Some simple interest I look at, and I know that this is cut off on your screen, but this is all in your book. So I'm looking at some interest and principal. Here's the formula for that, and then my distance formula. We'll use distance formula a lot. So in this example, I'm asked to solve the temperature formula for F. So I rewrite my temperature formula, and I see that F is over here with a bunch of other terms that I need to get rid of. So I see first thing I have is I've got some stuff multiplying by my parentheses, so I need to undo that. So I can divide by fractions, right? And I don't really like dividing by fractions. So the other way I can get rid of fractions is multiplying by the reciprocal. So the reciprocal, remember, is I just flip my fraction upside down. So I'll multiply each side of this equation by 9/5, which gets rid of my parentheses. Now I'm just subtracting 32 from my F, so I can undo that by adding 32 to each side, and then I simplify again. So I have 9/5 C plus 32 equals F. So then I can just go ahead and rewrite my formula. So I started with the formula where if I needed to find the degrees in Celsius, but now I have a formula where I can find the degrees in Fahrenheit. So now I'm looking at a word problem at which has the greatest surface temperature, Mercury or Venus. And I'm given a little example, and I see that Mercury's I'm given in Celsius and Venus I'm given in Fahrenheit. So I have to convert so that I'm looking at the same thing in both equations, in both examples. So I'm converting the Celsius temperature of Mercury to degrees Fahrenheit. So I'm going to use that equation that I came up with in the last example because I'm trying to find Fahrenheit. So all I need to do now is wherever that C was, degrees Celsius, plug in what I'm given for Mercury, and then I can do the math and solve it. So I know I'm going to do 9/5 times 427 and then add 32. So it's approximately 800.6. So I can't just leave my answer like that. I have to go ahead and actually answer the question. Because I was asked a question, I can't just write a number. So I could say that because 864 degrees Fahrenheit is greater than 800.6, Venus has the greatest surface temperature. Now this step is really important. We can't just leave our answer here because I didn't actually answer the question. I have to make sure that I use sentences and words to answer the questions that I'm given. Okay, so here's another one where we're going to be looking at that interest formula that you saw in that core concept. So if I deposit $5,000 in an account that earns simple interest, after 6 months the account earns $162.50 in interest. What's the annual interest rate? So first I have to solve my interest formula for R. So here was my interest formula, I equals PRT, and I wanted to get R by itself. So I see that I'm multiplying by a couple of things, so I just go ahead and I divide by those two things. And that gets my R by itself. So now I substitute the things that I know. I know that the interest that I've earned was $162.50. The principal's my starting amount, was $5,000. And I know that it was 6 months. And 6 months is 1/2 of a year. So I can go ahead and put this in as 0.5. So now I can just do this simple calculation and find it that R was 0.065. But when I'm looking at interest rates, I'm usually looking at a percentage. So I go ahead and I convert this decimal into a percent by moving the decimal place 2 places to the right. So instead of 0.065, I have 6.5%. And again, you'll see I answered using a complete sentence. The annual interest rate is 6.5%. Okay, so here's another word problem that we can look at. A truck driver averages 60 miles per hour while delivering freight to a customer. On the return trip, the driver averages 50 miles per hour due to construction. The total driving time is 6.6 hours. How long does each trip take? So here I'm going to be using the distance formula. Okay, that was on that core concept. So here I'm writing the expressions that represent my 2 trip times. Okay, so I'm solving the formula D equals RT for T because I'm looking for time. So I have T, time equals D divided by R. So D divided by 60 is the delivery time, and D divided by 50 is the return time, because I had 2 separate trips. So I'm going to have 2 separate expressions. So then I know that these expressions and the total driving time, so I can write my equation. So my total driving time was 6.6 hours, and I know that included the delivery and the return. So I can add these or find the sum that equals 6.6. So the first thing I want to do is I want to combine my fractions and simplify. But I cannot just add these fractions because they have different denominators. So the first step I always do when I'm combining my fractions is to find a common denominator. And one way I can do that is multiply the 2 denominators together. And I know that 60 times 50 gives me this 300. But then I have to change my numerators. Now let's go ahead and look at this notebook and we will do that together. So I have D over 60 plus D over 50. So I know that 60 times 50 is 300. So I can rewrite both of my fractions with that common denominator. And I know that in my first fraction, to get to 300 from 60, I multiplied by 50, so I have to do the same thing to the top, to the numerator. And in my second fraction, to get to 300, I multiplied by 60, so I have to do the same to the numerator. So now I have 50D over 300 plus 60D over 300, so I can simplify to 110D over 300. That's where we get this in this example. So I've added my fractions to equal my 6.6. Then I see I'm dividing, so I go ahead and multiply each side by 300 to get rid of the denominator, and then I'm multiplying, and I can to undo that, I divide. So I divide each side by 11 and then simplify. So my D is 180. So the distance, right, D was distance, one way is 180 miles. So then I can use my expressions from step 1 to find my 2 times, because I was asked how long does each trip take. So the delivery is 180 miles at 60 miles an hour, which tells me it's 3 hours. Then the return trip is 180 miles at 50 miles per hour, which gives me 33.6 hours.